Yeah, so we have a long stint now talking about digital twins and 3D. Have you been here yesterday? So you already know me, right? So I don't need to introduce myself again. So it's still me, Andreas Lippold, working for Esri as a 3D PM product manager, looking after the 3D capabilities across ArcGIS. And today I would like to talk a little bit about why we do 3D and what we do there, right? And how it ties into the digital twins, and then showcase a couple of examples. So it's a very long session, so if you have questions in between, so we can maybe discuss and talk about things, that's no problem. We are a nice, quite a nice small group here. So let's get started. 3D across the ArcGIS system. When I joined Esri, we were talking about 3D across ArcGIS as capabilities which we have, but which we do, which do not really belong to the ArcGIS system. So I came up with a little vision statement for us to work on those 3D capabilities. And what it says is like ArcGIS is enabling a 3D GIS, right? Making sure that GIS is also 3D, or 3D is an integrated piece, including an integrated 3D system of record. And I highlighted this yesterday as well. The 3D system of record is essential. And we saw also the presentation from Taru where they say, okay, we need to take care of the data so we can reuse them. So the integrated 3D system of record is very important for us. That builds smart environments, providing a foundation for the living digital twins, right? So the living digital twin is the biggest or the highest goal we can reach so far. And so we would like to work towards this goal whenever we create 3D capabilities. I showed you this slide yesterday as well, just reiterating on it a little bit. So when we do the capabilities and we are working on those capabilities, we look after these 4 pillars: the content piece, the visualization piece, and the analysis piece. And also looking into the immersive experiences. You have seen a couple of videos yesterday I showed you, which nicely present a digital twin as realistic as we can. So we would like to look after these immersive experiences in various ways on the apps, in the AR and VR experiences, and all those tools where we provide interaction with the 3D content. I don't want to dive into this too much, but this is how we look at the digital twin. I explained it yesterday already. So the 3D system of record is in the middle, and then we can actually go through maturity steps to build up those different twins. And this is how we interact with customers to start talking about digital twins, right? For customers, a digital twin is already a 3D model, which is okay, right? Which is like a first step in getting towards a digital twin. And when we dive deeper into it, like looking at more deeply into the architecture, then you see on the first level the data capture element, that we're looking not only at reality capture, like the meshes, but also feature extraction, 3D objects itself, right? You can build up 3D objects somewhere else and bring them in. BIM and infrastructure was a big topic yesterday when I talked to customers here. And all these data are captions, of the world. So we are creating this kind of data, and then we bring it into our ArcGIS system, which is the second tier. And in this, we do all this data modeling, data handling, data providing, data creation, right? We are managing the data, and then we share them out to certain people. And here you see also all the capabilities, visualization, analysis, simulation, interaction. All these things happen in ArcGIS. And then the third tier is SDKs and APIs, right? So we will have also a session here on the platform, I think, today. So this goes into the direction using APIs to connecting things, as well as using APIs and SDKs to customize and build stuff, right? Building apps, building applications, building workflows that suit your needs. And then real-time. Real-time is another thing that falls into this smart environments, right? Making things smart. So we are connecting them with IoT integration, with the IoT sensors out there. Also, we can use this information for tracking and positioning inside of objects or inside of a facility. And then last but not least, and I will come to that in later this day, to the applications and solutions. So I highlighted a couple of them yesterday already. So it could be focus on utilities, planning, operations, constructions, and responses. It could be anything what you have in mind to build up a first twin or twinified workflow. Maybe let's have a quick look at what people do in the Esri community. So I highlighted a couple of things here which show you nicely that people are working towards 3D, integrating 3D into our system. Can you see my mouse here? Yeah, okay. So in the upper right corner, this is actually a nice integration of a facility. It's actually a plant that has been brought into ArcGIS scene to visualize this whole plant. So this is simply bringing stuff together. On the bottom, you see an example from Sweco using GeoBIM, right, working on a construction site, combining ArcGIS Online and the construction cloud of Autodesk. On the lower end, you see a little image which shows you actually an example from Ericsson using our tools to verify 5G distribution across the city, right? So where do we need to actually place those antennas to distribute the 5G signal throughout the city nicely and efficiently? In the middle down here, you see the city of Utrecht I showed you yesterday already with a nice helicopter. So they are doing a lot of stuff with the meshes and creating a nice city model and using it for various purposes. So you can see here all the measurements for certain things they need to do, and also this using the JavaScript API in order to make shadow accumulation analysis and stuff like this. On the right-hand side, you see a couple of examples using game engines. Fosters and Partners, they are doing a digital twin of a bigger city in the Middle East. And they actually will showcasing this year at the UC in San Diego, if someone is there. Flood simulation in Paris is something that is done in the community very well. And there will be another tool, hopefully soon coming in ArcGIS Pro, that is really looking after real flood simulation. That is very exciting, but I cannot show it today. Down here, it's used. This is I think from Canada, an example where they used the city engine to figure out how to reorganize or reshape a city or road towards limiting the heat accumulation in those streets by replacing buildings and man-built structures with vegetation objects, for example, to cool down those street elements. So there's quite a lot of 3D upcoming. A lot of people do 3D, and it's nice to see that more and more people pick it up, also within Esri. As I said yesterday, Esri is a 2D mapping dinosaur, and it still is. So we are still needing to get customers' engagements to get the requirements of what they want to do and what they want to see. So maybe going back one slide. So I would like to go through these different tiers a little bit and explain and showcase you what we do here. So starting off with data capture. Okay. So in data capture, so when we think of data capture, right, there's a lot of stuff we can use. So unclassified LiDAR data, so we can use them to detect and classify complex urban features, right? So we have a lot of tools that extract features out of the point cloud that we can use in our 3D environments, in our ArcGIS system. Also, we can extract them, to be then part of the base map content. That helps to streamline, all the data and extracting those 3D base maps data for a digital twin. So this is actually the baseline how you get started, and it's becoming more and more efficient to do so, right? Because it's not so expensive anymore. Also, when you look, and I showed this yesterday, when you look into your current ArcGIS environment, you have 2D data, polygons, lines, points, right? And you can still use them. And this is what I showed you yesterday in the video, draping them across a mesh, for example. So you could actually see the data kind of elevated into 3D, and then it makes much more sense when you look at them. An easy approach, but a very effective approach. Another thing is what I showed you yesterday. On the right-hand side, you see the 2D floor plan, right? And just using them, using set values to extrude them into, a 3D building. Simple as that. And then you have suddenly a 3D visualization of your 2D information, which is pretty neat and handy. One thing more I would like to highlight is that we have those two new solutions. I don't know, you will have a session, no? You won't have a session here? Yeah? Okay, good. So he knows about it. So we have two new tools out there to actually create those nice kinds of meshes and other products. So one is the ArcGIS Reality Studio, which is really a standalone product for reality mapping at scale, large scale. And then we have the extension for ArcGIS Pro, right? For, I wouldn't say everyday use, but it's more easy to interact and doing some kind of mesh creation inside of Pro. Which is very interesting for us, so that we have this standalone product. As I said yesterday, we're trying to put everything into Pro. And that's actually a nice approach to do it outside of Pro and do this mesh creation at scale with its own product. And it's all based on the Sure engine, and the Sure engine came in when Esri acquired the company Sure in Stuttgart, I think 2 years ago. So when we now look into the ArcGIS system, I was talking yesterday about a couple of data sources which we are facing, right? There's a lot of data out there which we want to use and which we want to connect to. And we already can use a lot of these data sets. And it's not only about bringing them into our Pro application and use them. I showed you this slide yesterday. But it's also to get this data integrated and in a shareable form. So what we are facing, as what we are having as a baseline for our data sets is we have the imagery data, right? We have the feature layers in ArcGIS Pro, and what's new is that we have the scene layers, and the scene layers are a streaming file or a streaming format where we can easily stream large amount of 3D data across online and enterprise, and also use them in the desktop applications. And we would like to use those scene layers, right, to actually not only stream the data across different systems, but also author them, right? And then apparently publish them and consume them, and also then maintain them, right? So they are kind of our system of record for these 3D data sets to actually, at the end of the day, build up those digital twins. And so what we currently have is we have 1, 2, 3, 4, 5, 6 scene layers, and they are called I3S. I3S is the index 3D scene layer. That is an open geospatial standard, as you can see up there, and can be used for streaming various different data formats. Currently, we have the 3D object scene layer, that is using simple 3D objects, whatever it is, OBJs, whatever you have. You have the point scene layers, which is like the point feature layer symbolized with 3D objects. The integrated meshes, Jack calls them the 3D image of the Earth, right? Then we have the point cloud scene layers that are handling point clouds, streaming point cloud information across the web. And then what we have seen yesterday is the building scene layer. A building scene layer is using the information coming out of the BIM process. In this case, we are looking after Revit files, because we have this partnership with Autodesk, and we are looking after IFC. It has been built for buildings only in the beginning. Now we are looking towards how we can integrate more and more other man-made structures, bridges, tunnels, infrastructure, objects, pipelines, whatever is next. And the discussion is ongoing if we should probably need another streaming layer to provide for pipelines for the other architectures we have out there or not. And then we have the voxel layer for displaying discrete and continuous information across a certain space. So you can look after distribution of temperatures, pollution, soil types very easily. And this is something I can show you maybe in this little image here. So you have the point cloud scene layers displayed with 3D web styles. You have the labeled 3D object layer up here, the voxel layer, the point cloud layer, the building scene layer, and the integrated meshes. And maybe I could go into this one here. Probably it's nicer to see. So there's a little. Oops. Can you? I'm showing my screen now. I switched the application. Can I do this?
Wait. Maybe like this. Try. It is showing.
Okay, cool. So this is actually a nice example to show you what it's all about. So this is the scene viewer, and in the scene viewer you can actually create this 2D map, and then we can bring in a couple of more informations. One is the elevation layer, for example. 3D information, right? Then you bring in the imagery, right? Draping it on top of it. Then you can bring in the point clouds, the point cloud scene layer, right? As you can see, popping up here nicely, right? And then using the point scene layers to distributing maybe vegetation objects, right? Using simple symbology. 3D objects. Simple 3D geometry, and then combining it with mesh information. Oh, maybe this one here, the first one. Oh, now it's get cozy. Oh, nice. All right, Okay, and now you have seen, now you see the integrated mesh, right? You see the trees, the terrain, everything. And then, you can also bring in the voxel layer, right? Discrete and continuous voxel layers. You can use them in this case for different soil types, what is underneath your surface. Also, you can use the voxel layer for, showcasing clouds and stuff, right? Pollution. I don't know, yesterday we had the discussion with the port of Klaipėda, and they were looking into how we can showcase pollution in this area and where it's coming from, right? How is this distributed, and is it coming from the port, is it coming from the city, is it coming from somewhere else? So all of this can be done with the help of the voxel layers. Then the building scene layer, right? So the information from the BIM process brought into ArcGIS. So you can easily view everything that is inside and outside of the building, all the details in context of your meshes, of your simple 3D geometry, the trees, whatever you have in there, inside. Then you have also the 3D polygon features, which I showed you before, right? So using those 3D the polygons and extruding them into 3D, you can actually see the different layers or the different stories of the building. And the 3D line features to maybe show inner walls of a building, of a floor. And 3D point features. And all of these symbols, apparently these symbols don't make any sense because they are facing all in my direction, which is probably not helpful for the traffic, but this is something we can fix. And this, together is more or less our 3D system of record when we think about a digital twin and sharing this information out to my organization, to my people, to stakeholders. I found this pretty interesting, this scene, which gives you a little impression of what it is, what we do. And we are looking after, when I showed you the different data sets we would like to consume in ArcGIS, there's more and more out there, and people would like to see them in their system of record, in their 3D, in their digital twin environment. And we are trying to use those kind of scene layers to distribute this information and see how it makes sense. And then with the help of those different scene layers, you also have different abilities to work with those scene layers, going through the stories, doing profile view, and so on and so forth. So it helps really to work with the data across the web and building up those digital twin experiences. I will now try to switch back. Ooh. Okay, let's see. I don't see it on my screen here.
Okay.
Mm-hmm.
It's okay. Turn again this window. It's not showing for me.
No, it's showing. Perfect. Thank you. All right. And when I go back to this image, what you see this little star up here. It says with associated feature layer. So you actually see a couple of layers here, like the 3D object scene layer, the point scene layer, and the building scene layer. They all, well, let's start the other way around. When we create a scene layer, it's actually a snapshot, right? We extract data out of it, put it into a streaming file, and then we publish it. And the problem with that is that it's a snapshot in time, right? And you cannot interact with that. With the help of the associated feature layer for at least some of the scene layers, we have the ability to grab the underlying GIS features. So what we can do now in the web is that we can edit this kind of data. So we can change attribution and pipe them back into the system of record. So this way, the scene viewer gets more and more interactive, and people can start working with them. And this is very helpful when you start thinking about a digital twin, right? And interactively working with the data in the web. Another thing that points to the system of record, and I highlighted it yesterday, is that we would like to provide also 3D data for you to consume right away, so that you do not need to search for data and trying to scratch your head where to get 3D data from. This 3D base map is coming from OpenStreetMap data, so we licensed the data and created a 3D base map out of it, which you can really use in ArcGIS. So whenever you type in your location, wherever you are in the world, you can create a 3D, you get a 3D model or 3D representation of your area in ArcGIS and can populate it and start working with it. And that's really helpful, I think. And what we have in here is trees and buildings. Holy cow, okay. And then scene viewers, as I mentioned, so scene viewers are not only something, scene layers is not something that we use to be used in a browser, in our scene viewer, but we also use them all over the place in our own ecosystem. So we can pipe them back into our ArcGIS Pro instance, but we also have many, many apps that are using the scene layers. So you can use them in the scene viewer, as I said, which I showed you already. In story maps, you can use them. In experience builder, in web app builder, in the ArcGIS indoors environment, you can use them. ArcGIS Urban uses them to actually bring them in as context for their certain plannings. ArcGIS GeoBIM, which is built on experience builder, is using them. And the instant apps can use all of this stuff. Here's a little explanation for all these different apps we have. So it's actually, we are eating our own, how you say, dog food, right? So we are using those scene layers not only for publishing them, but also using them in our internal ecosystem, which is actually pretty nice and neat. So that's why it becomes an essential piece of our system of record. Another thing is that we also have the ability to use a 360 VR viewing capability in the scene viewer. So when you actually publish a scene, you can easily use this feature to actually view it in your VR experience, a simple scene, which I showed you in the beginning, which is actually pretty cool, and you can use it out of the box. So maybe let me quickly go over some of the web 3D experiences. We have done making a progress of supporting more and more data formats, right? So in order to perform and effectively provide immersive experiences and work on 3D visualizations. So on the left-hand side, you'd see various data supports I showed you already. For the immersive experience, it's actually pretty interesting. Some of the stuff have been shown yesterday. So we have weather effects. It's probably not essential for having a digital twin, but maybe for the storytelling aspect, it might make sense to actually use some of these weather surroundings to come across with your story very nicely. Also, what we did is the improved terrain shading, which really improves the way how you visualize the underlying terrain with the help of shading effects. So making sure your 3D geometry comes across nicely on a still flat screen. And then on the styling side, sketched edges and all this stuff, this is similar to the terrain shading effects, which makes a simple geometry look more plastic on screen. And again, this not only relates to a building or some features which you see and which are in your city, but it also reflects information, statistical information which you want to see in a context of a city in 3D. So like different, I don't know how you call it, polls, which show you different numbers across the city, where people are, what's happening there. So it all helps to actually visualize the content in 3D. And then this is stuff what we, looking at to enhance the scene layer capabilities in general to make it more dynamic and workable as a system of record. And it's not a snapshot in time, which we simply view. So we are connecting it with more and more features like this. So it's a feature layer and more to actually edit them. And you can see a couple of things here. You can do the feature transform, creating tooltips, masking. So you can actually mask out a certain area, flatten out area, so you can actually plan inside of it. Think about a mesh, and then you draw an extent, and then you can flatten it down so everything is flat, so you can go in and do your initial planning. Yeah, vertex editing, snapping, so all this stuff is already in there, and you can actually work on top of the scene layer in your web browser, which is actually pretty cool. And then you have the different analysis things here, like the persistent line of sight. So you can actually do those line of sight analyses. Well, and then you can actually store them in your bookmarks, in your slides, and come back to it later. So you can actually prepare this in your presentation, in your scene viewer, and then come back to it and showcase the different line of sight analysis, dimensions as well, which is pretty helpful to measure inside of a city, to figure out what's going on. And the terrain profile is also something which is very helpful for analyzing circumstances which you may have. Switching over to SDKs and APIs. So there's a lot of stuff people can already do with the ArcGIS platform, and I think they will go over it in the session this afternoon, right after lunch. We have a lot of SDKs and APIs on various locations. So Earth has an API, Pro has an API, City Engine has an API, and we have many JavaScript APIs that help you to provide all this cool stuff which I just showed you in the web, so you can build up your own applications. Apparently, the experiences are pretty diverse, so we try to work on consolidating them and also aligning like what the JavaScript API is doing and what the apps are doing. So what the apps are doing should also apparently be in the JavaScript API, so you can actually use it and work with that. There's a whole platform for the development people to start investigating and work of that. And then also we will start working. Retitus talked about no-code, low-code yesterday. For example, in City Engine, we have a whole engine that creates content, right? It's a procedural 3D content tool, and we are using this, or we are not rebuilding it, but we are putting on top of it an easier access, so you can easily create this 3D content without diving into a code level, right? And there are so many things that we do, and hopefully this helps our customers to build on top of our applications. One thing to highlight here is like the ArcGIS Maps SDK for JavaScript, right? So this is the Maps SDK, the JavaScript API, and if you're interested in, there is actually a developer's ArcGIS domain that shows you. Okay, this is. It's not working good. Okay, there's actually a web page that shows you how to, for example, work with a building scene viewer, and how to adapt it and make it into your own application. So you can create different menus, different access points, how you access maybe I can, but if I go and switch, but we have plenty of time, right? Maybe I remember what you did.
Wait a little bit. Maybe switch with. No, okay. And change. Open up.
Oh, okay. That's the wrong one.
Wait a little bit. Maybe screen. No. Again. now.
Anyway, maybe.
It's Chrome or not.
Oh, now it works. Awesome. Okay, cool. So, so you have, you can actually view the code, and you can also view the live demo.
It's this or not?
That's not. Okay. Anyway, but what you can see here is, this is like the customized view. You are using the building scene layer, and then you can customize it according to your application you want to create around those scene, the building scene layer, right? In this case, it's a library in New Zealand, and they created this kind of nice, you see the opening hours, and then you can go through the different entrances and the building stories and find your way through the building within an app. So that's actually pretty neat. And then you have also you can view the code, and you can actually learn and how to do it, and provide this to your developers, for example. Let's go back to the presentation. Yeah, okay, good.
Wait.
Okay, I won't do it again.
Okay. It's this one, yes?
I think so. Yeah. Okay. So this is another page, but you will find it. This is simply a page from when you search for the City Engine, and City Engine is a tool, as I said. It's a desktop tool which creates 3D models of a city. With the help of an engine that produces this parametric content. On the other side, City Engine has a lot of plugins for the different tools which are out there. Plugins for the different game engines. So it's more like a plug-and-play connection to the game engine worlds. And you find a lot of plugins there. And City Engine is picked up by AEC companies a lot during these times to actually highlight what they have. So when they brought together GIS and BIM data, creating those scene layers, and then highlighting them throughout the City Engine plugins in a game engine environment, which is pretty cool. So I can give you this, you can find it on the web. So if you search for ArcGIS City Engine, and then you find the plugin page, and scroll down and see whatever they offer. Then we also have SDKs for game engines, and there are two of it. One is the SDK for Unity and for Unreal. So this is a real SDK, whereas City Engine has a plugin where you can easily connect and transform your information into a game engine world. The SDK for game engines we also have for the native apps, so like Earth and all those apps which are out there from our end can also use the SDKs to create best mobile experiences and creating your kind of workflows on top of those. Time-enabled 3D data. So this is an interesting thing for us because more and more data is moving and has a time element to it. So we are looking at integrating IoT sensor information, and also looking after how we can track and use positioning information to verify where assets are and what needs to be done in order to bring assets from A to B. So we have a couple of things, Geo Event Server and Velocity. I'm not sure if you have a session on those things here, not this year. It's fairly new, and it's probably also something for big enterprises and not for small and mid-sized customers. But anyway, so this is something where we can track and store and use this information. For us, as the system of record, we would like to bring this information into our scenes, into our 3D scenes I was talking about earlier. So this is something which we really like to encounter and see how we can bring this information into those scenes. The other thing is that once we bring this information into our scenes and connecting sensor information, you see them live on screen, but we need to store them in our databases as well. So we have GeoVensor, we have Velocity, and Indoors and IPS as the tools that are looking after time or position of assets throughout time. Maybe here's a good example of one of these real-time, put it's running. Yeah, so this is like a campus owner-operator kind of situation or twin. They are tracking security, for example, and so they can actually do all these line of sight analysis to actually see from which point you can see what in order to make it a secure place and manage all the facilities in that campus, for example. There you saw actually the line of sight analysis, right? And then you can actually see, I think it's in there somewhere. Yeah, now you can look into buildings using the slicing tool for the building scene layer. And all these things can be done with the help of these kind of...
Working good?
Yeah, it's working. Can be done with the help of the information we provide throughout the scene layers. Location tracking is another element. So we are using this, and I don't know if you have seen the presentation at Dev Summit this year. So there are a couple of interesting use cases in skiing fields, for example, tracking all the machines that are running around the track to make it workable for the next day again. And so you have many interesting use cases. Also in the port domain, people are using this for tracking their assets across the facility, so they know exactly where things are. And interestingly, we had a nice use case from the Deutsche Bahn in Germany, and they have those huge halls where they drive in their trains to take them apart, look at every piece, and build them together again. So it's a maintenance garage. And interestingly, they are using asset tracking because they are taking apart the train. Now they have this part of the train, I don't know, the wheel, and they put them on different trailers so they can drive them to the garage where they get fixed. And normally they had 2, 4, 3, 5, 6 people running around searching for those trailers, which one is free. For me, it's somehow unbelievable, but this is the reality. And now with asset tracking, they know exactly where a free trailer is, and they can actually pull from there. And in ports, it's different. It's a similar situation. So you have a ship coming in, and then you need certain equipment to unload this ship. Where is the asset? Do I get this asset to the ship, right? Other stuff for maintenance, right? You have a facility, and that you need to rebuild something. Can the track pass till he reaches the position where this thing needs to be built? So there are all sorts of things that can be helpful in a digital twin to realize, what is there, what can be done, and what may be the impact. Yeah, I showed you this example yesterday. I think this is a nicely done presentation using different visualization techniques to make this a nice visualization, but also helpful visualization, right? It's kind of a dashboard application that shows you what's going on there. What is going on inside of the turbine, what's going on inside of the network, and where is this network lacking because one of those turbines is kind of not functioning correctly. Yeah, and those kind of things we would like to highlight in our ArcGIS in terms of 3D assets, connecting them to a network which is already there. And apparently it's not everything needed to be in 3D. Also in 2D, it makes a lot of sense to have some of those workflows displayed on screen and manageable for people. And with that, I would like to dive into the applications and solutions. And now you have seen a couple of capabilities which we are building up. And now when we think about applications and solution, all these capabilities tie into it, and then you can really do stuff with your 3D environment. I know I showed some of these slides yesterday, but still it's like a nice getting into the applications and solutions. And when we think about applications and solutions, we are thinking about a digital twin at the end of the day, which helps to solve some of those problems. And I was talking about them yesterday, and I don't want to reiterate on those. But the essence of a digital twin is actually connecting different types of data and making them manageable within an environment, which is the digital twin. And at the end of the day, you are not only managing it because you are creating this nice depiction of the world, connecting it to the sensors, but at the end of the day, it can automatically run for certain circumstances because it learns from the outside world, and it can actually then replicate, the physical world and pipe it back into our conceptual or into our digital twin. We can do stuff, and the response then can go back to the physical world, right? Because it knows exactly what to do. So again, just to reiterate, digital twins are a virtual representation of the real world, including the object itself, the physical object, and the processes and the real-time behavior of that object, right? So if we simulate stuff, we know exactly what it's doing in the outside world. And we know also exactly what it's doing right now, because we are connecting with the sensor techniques and know exactly, oh, this is happening right now. And then we can simulate and do stuff and give the response back to the physical object. And as I said yesterday, it's tricky when you think about the built environment, like a whole city. It's so complex, right? It's not just a complex city engine, right, which itself is very complex, but the citywide scale is very complex to have so many things going on in parallel and stuff affect each other. So it's a very new field, right? And when people come and say, "Hey, we need to build up a digital twin of a city," then okay, let's go back to maybe starting to search for the problems we need to solve and start from there, and then keeping in mind that the data source you are creating might be reusable for the next twin and the next twin, and then at the end of the day, you may come towards that vision of having a holistic twin of a city. Again, not iterating on this one, but for me, the interesting piece why I'm talking about digital twins and 3D, these problems have been there years ago as well, but today we need to be more quicker in resolving those issues, right? And also, at the other side, many more people are involved in solving these problems. And we are not talking only about GIS professionals anymore, right? We are talking about everyone who is living in that city, and many of those people using GIS information, but they don't know that this is GIS. So we need to provide this information in a way that people actively can step in and help solving the problem without being a professional in some sort of GIS applications. So when we look at why we are using digital twins, because it allows, to actually, look at the characteristics and behaviors of a physical system, and then, look at the situation and maybe try to solve this within a safe environment, right? And then once you have found a solution, you can go out in the world and fix that problem or let it fixed, right? You see a couple of examples on this slide. So it's actually a kind of a test environment for the physical world. And if you will, then connect it to the physical world, and then it helps the physical world to readjust. Another slide you saw yesterday, but just giving you the impression the market is pretty huge, right? So everyone is talking about digital twins, and this is a huge business. And I want to maybe re-emphasize on this one, because when at least for me, when I go to exhibitions, I see a lot of startup companies talking about digital twins. So when you pass their booths, you see the big screens and you see a nice model, right? And most of the time, it's a nice rendering of some sort of 3D model. This is not a digital twin. It's like, capturing people to build up a digital twin with a nice representation, and everyone is jumping on it. You really need to think about a digital twin as a tool. It's not a nice picture you have in your, in your pocket to show everyone and say, my boat, my house, my blah. No, it's a tool. It's really a tool. And a tool does something. It helps you to solve a problem. And GIS is the foundation to solve these problems. It has all the relationships. It has all the tools to analyze, right? Now we're leveraging into 3D, and we make it more connected and smart. So think about that way. Look behind the nice picture. And interestingly, 75% of the people asked are working with or planning to work with a digital twin. Only 13% are using it, and this is actually the interesting number, because I'm so keen on the system of record. You are not building up a twin for that purpose, and that's it. You're building up to solve a certain problem, but the underlying data has the purpose to fuel more twins, bigger twins, other problem-solving workflows. Then it comes back to recycling the data. Okay, nice graphic. But when we think about, bringing all this data together, especially when you think about BIM and GIS, right? It's not an asset or something in the world. It's not a singular thing that pops up and is there. It has a life cycle, right? And managing all these things throughout the life cycle is connected to information, to an information flow. And if everything is somehow siloed, you will always have these cracks in the middle between the different steps, right? You have a full drop in the information, and then you have to reinvent the information or find the information, right? And this is where a GIS and then later on a digital twin may help, because it connects all the information, and the flow of information is probably pretty nice and good to handle. So going quickly over this one, I showed you this yesterday. Everyone, kind of is aware. So I talked about cloud collaboration, which is a huge benefit. That's why we can actually share these scene layers nicely today. We have those technologies to stream this stuff, not exporting, importing, but easily distribute this stuff across. AI and ML helps us to identify and manage the data and find problems, help to solve problems, help to identify things in the data we have. And the game engines, as I said, is something that really creates the realistic or the immersive experience, so we understand the problem. And this one is, again, the city of Utrecht I showed you before. Again, we are building from existing approach, so everything is in GIS is something we can already use and leverage, which is actually pretty much the foundation for everything that digital twin is related to. And yeah, maybe a nice thing, going back to this one here, is that the ArcGIS system is having, is an ecosystem of purpose-built geospatial engines, right? And this enables you to capture and manage data, integrate real-time information, automate and predict outcomes, perform end-to-end analysis. So when you read through this is really, an essential piece of a digital twin. Again, my beloved circle. But when you look at it from a different perspective, just from an ecosystem, you have the data, right? Different data types you're dealing with. You have the ArcGIS system, right? even when you look at it from not reading it, but you see there's a lot of stuff already there which we provide throughout the ArcGIS system. Then you have the APIs and SDKs. You also can connect to other business and enterprise systems. And then on top of it, you have all these different applications which we already provide, which can help for identifying, or which can help to create those twins, to help managing those twins and being themselves the twins. And I showed you this yesterday, so like the data and reality capture is the bottom line, and then you can actually look after those different twins. I only have 4 here. Here were a couple more, right? So it depends on the problem, right? Think about the jet engine. It's one simple twin. Within a city, you may have many jet engines of different sizes and scale. So when we look into the reality capture, right? Reality capture is something you capture from aerial, from lidar, from flyovers, and you create some kind of meshes. You can create point clouds, and then you can combine this with the information you have in your GIS. This is a nice example of the city of Almere in the Netherlands. They actually have created, they are using this vector data overlaid on a digital terrain model. They are using also then the LiDAR point clouds and bring them in to visualize different height levels of the terrain, because Almere is below the sea level, so it's pretty important for them. And then they're also using then the generated mesh out of it in combination with the 2D information I showed you before, right? This is a 2D polygon, and now you can simply grab the building and get all the information out of it. You are able to, to see the polygons in your feature database on top of the mesh, which gives you the impression, okay, this is the parking lot of this particular house. And then you can use tools for measuring in the mesh and analyze it as you go. And I think also in this video it shows you nicely the environmental settings. Yeah, here. So now you can turn on rain, and because it's Netherlands, it may rain more than here. I don't know. So this is more or less then the foundation, bring all this stuff together, right? And then you may think about the environmental hub or environmental twin, right? Many communities around the world are starting to realize the potential of setting up simple open data portals, right? And we have developed a technology called ArcGIS Hub that extends to open data portal concept through initiatives that can align open data with projects and use cases supported by that data. And one of those examples is here the city of Zwolle, again in the Netherlands. And they have published their initiatives along with maps and apps in addition to their open data portal. And what you can actually do is here you can search for those data sets both in 2D and 3D. You can preview them, explore them, and then at the end of the day you can download them, right? So it's an easy way to connect people to data. Another kind of thinking process might be a spatial planning twin, and this is designed for city and regional planners and architects to support spatial planning. And we have 2 applications for it, like ArcGIS Urban and ArcGIS City Engine, as I mentioned, to do these kind of planning scenarios and create this content for your planning, and also at the end of the day create this nice output using the game engines. And again, another example here is from a municipality in Karlskrona in Sweden, and they are using, this is Urban. No, it's a web app, right? So what you can do is you can actually use certain policy zones to create a certain planning in terms of how high is the building, how many stories, what kind of usage this building will have. You can create different alternatives based on the underlying restrictions within that area, right? So you see different colors. This is the different usage of a building. You can lower the building, you can higher the building, you can, do whatever you need to do in order to make a good assumption of what this new planning will look like. Also, you can use the side-by-side view of seeing what's there and what is planned. How does it look like, right? So there's so much stuff you can do on basis of your system of record, right? Using a mesh, bringing that in, and then plan in that mesh, and then you can do this kind of accumulated shadow analysis. And other things to make sure these buildings do not affect inner city climate and weather effects. Another idea could be a design and construction twin. So GeoBIM has become a very important concept and challenge that that Esri and Autodesk partnership is trying to solve. And one of these examples is this is I think it's a bridge model along the Atlantic Road in central Norway. So they are using GeoBIM, right? And during the design and construction process, it's a live connection that can be made between the geospatial model in ArcGIS, right? And then on the other side, on the design and construction cloud within Autodesk. So it's a live link, as you can see here. On the right-hand side, you have the Autodesk cloud, and on the left-hand side, you have online representation with all the context. You can resolve issues, right? Issues going back and forth between two systems. You can actually resolve them. So it's more like from a project management point of view throughout the construction phase to see what's going on and share information, and also do, at the end of the day, analysis inside of Pro using the information out of the construction cloud in Autodesk, And this is it coming here? Yeah, here, like this, right? So you can go in and do the flood analysis and see how your bridge is doing when the flood is coming. So this is very important for them to do so, and this is not something that we can do alone in the ArcGIS world or alone in the Autodesk world. It can only be done when we bring both systems together. Network is also something you might be interested in. Looking after electricity, gas, telecom, water, all the complex networks need to be handled. And there's also a nice example in Dubai. Let me click on that. Which combines the 2D information, the 2D network information with the 3D elements, for example, in this solar park here. So you easily can manage these things, as well as you can manage these things in accordance to what their sensors may say. So you can actually go out and see, okay, this particular whatever station tells me this and this because it's happening right now there and there, and then you can actually trace along the network what you need to do. And last but not least, maybe looking into operations, right? We talked about indoor navigation, asset tracking, management of spaces. Yeah, you see traffic management, facility management, asset management, operation maintenance, wayfinding. All this stuff can be done based on the information we receive from the BIM world, so we can use it in ArcGIS with all the tools to do these kind of things. And a nice example here is CERN. CERN is one of the most advanced customers using ArcGIS indoors, and it's placed in Switzerland. It's home of the world's largest particle physics laboratory in the world, and it manages 18 sites, 700 buildings, and it looks after, it manages the complex equipment, outdoors, undergrounds, and indoors, inside of buildings. So everything is managed through the indoors tool that holistically can build up this twin for this particular campus. So you not only manage your systems, but you also manage your spaces. You can reserve spaces. You can manage security through the spaces, lock down certain areas for certain people. People can go in and reserve spaces to work in. And so CERN is the largest laboratory in the world and continues to grow. And CERN is also, their future is also supported by their indoors operational twin. So these are a couple of examples to showcase you what people do in terms of digital twins based on the information you have in your GIS, leveraged by the 3D component. And our 3D system of record and the scene layers are an essential piece for it. And I think I'm more or less done. So my last slide was this one, which gives you, again, the little impression of how to think about a digital twin. And when cities say they want to become a smart city, then it has many tools and concepts that relate to be a smart city. You can actually order your passport through a web page, which is already a smart tool, or a tool that relates to a smart city. Also, other digital innovations can be used as tools to become a smart city, and a digital twin is one of those tools. So you can build up a tool like this operation twin I showed you last, right? Can be used within the city to manage your, main train station. I don't know, some of you have maybe, I don't know if you have been at the IMGS this year in Frankfurt, and they are starting to manage their whole main train station using these indoor capability to manage the train station. So this can be one piece of tools to provide a smart city at the end of the day. And the underlying structure or the underlying foundation is the GIS system, because it provides all the transactions, the assets, the relationships, right? Because it creates those digital twins of the social, natural, and built environment, and uniquely integrates and interconnects many of these, many of the types of digital models. So we already can do a lot of stuff. We just need to be more open, more connected, and this is what we are working on based on our scene layer concept to make these digital twins workable for you throughout the different applications we provide. Either it's urban, it's pro, maybe it's city, it's GeoBIM, and many other tools. We don't call them twin, but at the end of the day, they do exactly what you need to do. And I think with that, I'm done for today. Thank you.